Welcome to The Explainer. Today, we're diving into something that is, honestly, just mind-bending. We're looking at a source that bridges the highly technical world of acoustic physics with ancient sacred texts to solve a genuine mystery about fluid dynamics. It's a groundbreaking study that completely challenges how we understand the relationship between sound vibrations, physical matter, and purification. So get ready, because the science we are about to unpack is absolutely wild.
So I want you to consider this question for a second. Can the sound of a single word physically alter the geometry and purity of water? I know, right? It sounds totally like science fiction. We usually think of water purification as, a chemical or mechanical process. But what if a specific spoken frequency could rearrange water on a microscopic level? Well, that is the core mystery we are unraveling today, and I promise you, the results are going to completely change how you view something as simple as a drop of water.
Section 1. That hovering water droplet. Picture this, inside a high-tech lab at the Hydroacoustic and Fluid Dynamics Research Center in Singapore. You've got two brilliant, but very different scientists looking for answers. On one side, we have Dr. Laila Al-Farsi. She's the head acoustic physicist, and really, she's a visionary, looking to see if sacred words have a measurable physical reflection in reality. On the flip side is her colleague, Dr. Rajiv Kumar. He is a strict materialist mechanical engineer. For Rajiv, water floating in space is just following the strict laws of physics. He firmly believes concepts like purity have absolutely zero bearing on mechanics. It's a dynamic clash of perspectives, and it sets the stage perfectly for what happens next.
So what exactly were they doing in this lab? Well, they were utilizing acoustic levitation. Basically, Laila built this specialized hollow cylinder equipped with ultrasonic transducers at both ends, and these devices generate incredibly powerful 24 kilohertz standing sound waves. Right in the middle of this chamber, trapped in the zero-pressure nodes of these waves, floats a tiny 2-millimeter droplet of distilled water completely suspended against gravity. It's an incredibly precise, high-tech environment.
Now, Laila's hypothesis was actually sparked by a specific text from the Quran, chapter 25, verse 48, which mentions water sent down from the sky that is tahurra. That translates to exceptionally pure. Laila started to wonder, does this specific word, tahurra, possess an actual physical or geometric reflection? Could reciting this word literally alter the molecular structure or the surface tension of that floating water droplet?
Section 2. Geometry and tests of sound.
Okay, so to see how the droplet reacted, they projected different audio inputs directly at it. When they played white noise, the droplet pretty much just stayed round with some random surface ripples. When they played jazz music, it turned into this shaking oval. But when they played a slow, emotional recitation of the word tahura, the high-speed cameras captured something that seemed completely impossible. The plosive sound of the first letter, ta, created a permanent asymmetry on the droplet's surface. It literally stretched into the shape of the Arabic letter ta, then rounded out for ha and elongated for ra. The droplet literally morphed into a 3D hologram of the word itself. No way, right? Now, Dr. Rajiv Kumar was naturally pretty skeptical about all this, and he actively tried to debunk it. He whipped up a synthetic, 15-frequency multitone that perfectly matched the audio spectrum of the recitation. But when he played his synthetic version, the droplet just shook randomly. Laila ended up pointing out the flaw. Rajiv copied the spectrum, sure, but he completely missed the time domain phase. You see, the natural human voice has a 50-millisecond transient shift, just a tiny, microscopic pause between the explosive ta and the friction-based ha. That split-second perfectly human element is what triggers a phenomenon called Rayleigh-Taylor instability on the water surface, which ends up carving out the exact curves of the letters. But Rajiv was determined to find a random cause, right? So he takes this to his supercomputer. He tested an astonishing 10,000 random phase shift patterns to see if any other combination of sounds could replicate that specific droplet morphing. And he failed. Out of 10,000 attempts, only the exact primary waveform of the word tahura actually worked. That's when Rajiv realized this wasn't just random chance. It acted like a highly specific, programmed acoustic code designed exclusively for this recitation.
Section 3. Cavitation and the science of purity.
So, you might be wondering, how does changing shape actually clean the water? Well, to understand the purification part, we really need to understand acoustic cavitation. These are basically sound-driven microscopic bubbles that form inside a liquid. Laila zoomed in on what was happening deep within the floating droplet while the word was being played, and she observed something extraordinary about these tiny bubbles. Because during the recitation of Tahura, these cavitation bubbles didn't just pop randomly. No, they formed a highly organized spiral path, structurally sweeping through the droplet. This acoustic spiral acted almost like a broom, physically pushing impure particles outward to the very edges of the water. And even more incredibly, when Lila measured the water afterward, the electrical conductivity, which is a key indicator of dissolved impurities, had dropped by 15%. The sound was literally physically cleaning the water.
And the absolutely crucial point here is the hard data from Rajiv's follow-up modeling. Check this out. When testing sonochemical pollution reduction over 2 hours, standard ultrasound frequencies only reduced impurities by 20%. But when using the exact acoustic frequencies of the Tahura recitation, pollution dropped by a massive 80%. The acoustic frequencies were literally recalibrating the water's hydrogen bonds to actively purge contaminants.
Section 4. Laser and Verse Hologram.
All right, this brings us to what is essentially the emotional and scientific climax of their research. To grasp what happens next, we have to talk about something called a GRIN lens, or gradient index lens. Normally, water has a uniform refractive index, meaning light just passes through it predictably. But Lala discovered that the highly organized cavitation bubbles we just talked about were actually stratifying the optical density of the water droplet. The sound waves were so incredibly precise that they turned the droplet of water into a dynamic optical lens capable of bending light in really complex ways. So, Layla takes a red helium neon laser and literally shines it directly through this acoustically levitating, morphed droplet. And because the droplet had become a GRIN lens, the laser didn't just pass straight through. It refracted dynamically, projecting the exact geometric curves of the Arabic script right onto the chamber wall. It actually projected the very verses they were testing. Think about that. The acoustic envelope of the word had physically shaped the water into a lens that projected its own name.
The sheer physics of this moment just deeply affected Dr. Rajiv Kumar. The source notes this was a complete paradigm shift for him. As a strict materialist who had studied fluid dynamics for 30 years, seeing water act as an intelligent lens basically shattered his previous worldview. He realized this specific sound wasn't just bouncing off the water, it was purifying it by fundamentally rearranging its internal architecture.
Section 5. Ma'un Tahura, a new chapter.
So what do we actually do with this incredible discovery? Well, Lila codified it into a mathematical model for sonochemical water purification. It works through this precise dual resonance mechanism. First, the pronunciation of ta hits 24.5 kilohertz, which resonates perfectly with the stretching vibrational mode of water's hydrogen bonds. Then, the ra sound drops to 23.7 kilohertz, triggering a bending mode. This 1-2 punch extends the lifetime of the cavitation bubbles, allowing them to sonochemically sweep out impurities without even relying on gravity. It's basically an acoustic operating system for purification.
And the real-world impact here is just profound. Lila's lab, which is now renamed the Ma'un Tahura Research Center, is actively developing affordable acoustic water purifiers for developing nations. These devices use a hollow chamber and continuous audio playback of the recitation. So using just electricity to power the sound waves, contaminated water is slowly, continuously, and efficiently purified without any expensive chemical filters. It is such a brilliant, practical application of acoustic physics for global good.
Which leaves us with this really powerful final thought from Lila's upcoming book, Water Listens. When you fill your glass with water, is it Tahura? Is it truly pure? This research strongly suggests that water is deeply responsive to the vibrational environments we expose it to. It really forces us to wonder about the profound, hidden connections between the words we speak, physical frequencies, and the very molecular structures that sustain our lives. Thank you so much for exploring this fascinating intersection of sound and science with me today. Until next time, keep questioning the world around you.